Hi. So today we're gonna have another reinforcement learning series. Okay. So the reason is that recently we have a very popular large language model called DeepSeek, right? So the success of DeepSeek, it largely is due to the reinforcement learning algorithm. Okay, and we're gonna see the underlying reason behind that. Okay, so this paper for the DeepSeek R1, so it based on the previous DeepSeek models, and it also provides a very efficient reinforcement learning algorithm to help the models to train itself. Okay, and later we'll see how it does those things. Okay, all right. So, and we can see from the first page of this paper, and this model, the R1 version, it outperforms a lot of other models, including the OpenAI O1 and the mini version, right? And some of those tasks, especially in the reasoning problems, including the coding or the math problems, or all of those reasoning problems, it has a very competitive performances regarding or compared with the O1 models. Okay, so now let's just directly dive into the important part of this reinforcement learning algorithm. Okay, so this paper, okay, so it says it's using the group relative policy optimization. Okay, so it's GRPO. It is also a work from their team, right? And this is just a another version, or it's a development, a further development of the PPO, right? So later we'll have another video, another episode to talk about the PPO, but here we're gonna briefly introduce this GRPO. Okay, so essentially this policy optimization algorithm is, here we simply wish to maximize our rewards, right? And by choosing, or by and to choose some optimal policy model, pi theta. Okay, so that's our key to optimize here, right? So we have this as a group of outputs from O1, O2 up to OG, and those from the sampled from the old policy pi theta old. Okay, so here the we're gonna optimize the policy model pi theta by maximizing this objective. Okay, so in this objective function, so the first term here, that'll be an expectation. Okay, so this is the expectation of the old policy. We can see here, and those OIs, those are just sampled from this old policy. Okay, so the next we're gonna have a weighted average of something. Okay, and we'll talk about all those terms inside of this weighted average. So we have a minimum here. Okay, so we'll talk about this later. So here we have this fraction. So this pi theta over pi theta old. So that talks about, so this denominator here, this pi theta old, it says something about how model responded with this old policy, okay, and how it uses the old policy to answer the questions. And correspondingly for this numerator here, that'll be how the new policy answers the questions, right? How we're gonna use the new policies. So this relative, so this fraction here, that is multiplied by this AI. So this AI, this term, that'll be a we have this here, right? So this is called the advantage function. So this AI, this is some new work in this GRPO, right? And this is a revised version of the PPO, and here we have this for each group. But in other words, this a function here, that'll be just some standardization value. Okay, so together, this term altogether, it simply shows that gives us some intuition of compared to the average reward, then how well does the new policy increase the reward, right? So that'll be the first term. So next, inside of this minimization, we have another term as this clip and multiplied by this AI, right? So we have this clip function here. So that'll be just something to make sure that this RL training to be stable. Okay, so it technically it restricts how much a policy can change. Okay, within some epsilon, some range. Okay, so we do not want this change of the policy to be too much when we're training the model. Okay, so we do not want the policy to go up and down and for too much. Okay, we just want the reward or the policy change slightly and increase the reward slightly, right? So that'll be our goal here. Okay, and we can see that this is also multiplied by some other term. This is also AI again as before, right? So this is also for the standardization. So and we put those two terms together and we take a minimization. So we want this change of this policy to be minimum, okay? But we are actually maximizing the objective function, but we at the same time we want to minimize the change of the policy. So that's it, right? So here we have another term inside of this weighted average. So that is given by this KL divergence. So that measures the divergence of different distributions, but that'll be having a similar usage, similar to the ones before. That is, so here this also is a sort of a regularization term, right? So for this KL divergence, we want also to stabilize the model training to make sure that the policy doesn't change too much during the training. Okay. All right. So and in all so here this expression here, this objective function, it simply says that we we wish to maximize the total reward by minimizing the policy changes, right? And there are some technical details, but we could look up the search for the papers and try to understand all the other technical details. But in short, that would be the key idea of this reinforcement learning algorithm. Okay, so this is just some development from some previous RL algorithms, right? So in the literature, but there won't be nothing very special. Okay, but something very special for this paper and for the R1 model of DeepSeek, that'll be this architecture or this workflow, right? So this workflow here, it combines both of the CoT and RL, okay? So essentially here we have this template, right, for this R10, this model. So it says the conversation between user and assistant, and then ask a question, then the assistant solve it. So they ask the model to first put the thoughts beside those two tokens, right? Think and slash think, right? So we're gonna put that between those two tokens, and then also put the answer between the answer tokens. So that'll be the structure of this workflow. So essentially, people are telling the model to think, to solve the problem in the chain of thoughts, right? So to think the steps, or to think out loud of all those steps, right? So so the people just tell the model to think those steps out, right? You're gonna have to list all those steps explicitly. So that's what we're talking about here, right? So this is the CoT part, and the magic is that they also combine this CoT with RL. So they put RL rewards as the incentives, right? To guide the model to learn by interacting with themselves, right? So as long as this model could put the correct or more and more precise thoughts inside of those tokens, and also put a more precise or more accurate answer into between those tokens, as long as the model could do better and the model can get higher rewards. So that is guaranteed by this RL rewards as the incentives, right? And so those two things combined together, this makes the this R1 model of the DeepSeek very powerful, right? So, and we can see from other illustrations in this paper, you see that this here in the accuracy rewards, the accuracy reward model evaluates whether the response is correct. Okay, so, and you can see that the DeepSeek R1 0 to first produce the reasoning process followed by the final answer, and that will be still the workflow, right? So here we can see in this little picture that this model outperforms even the O1 up here, right? And you can see that those thoughts they could even approach to a 90% accuracy, right? That is pretty high. So in all those reasoning tasks, right? So and here it says that the DeepSeek R1 0 to attain robust reasoning capabilities without the need for any supervised fine-tuning data, right? So it's purely relied on RL algorithms. Okay, so this is something very new, and this underscores the model's ability to learn and generalize effective through RL alone. Okay, but and we again, as we mentioned, so the key again itself is not RL alone, right? So the key is also the design of this workflow. So we're gonna let the model to think by themselves, think out loud by themselves for all those steps explicitly, right? And to correct themselves step by step. So you can so the most important part is that we tell the models, so we teach them how to learn, right? So we tell them you can you can do this by just to step by step COT thinking, and then if you do this and you can revise your thoughts, and if you really revise your thoughts and you see that now you obtained a much higher rewards, then that is somewhere that is something provided by the RL algorithm, right? Good. So and all those things we just mentioned, that goes to those sections in this paper, right? And we can see that so this is also a part of reflection process, right? This is very just like human beings, where the model revisits and evaluates the previous steps and the exploration of alternative approaches to problem solving spontaneously. And behavior is not explicitly programmed, but instead this is emerged as a result of the model's interaction with the environment, right? Okay, good. So, and again, so we say that this is learning by talking to themselves, and has to be explicitly, right? So write all those steps, all those COT explicitly, and then correcting themselves to try to improve the performances or the accuracies. Okay, if those are improved, then they will get a higher reward by the RL algorithm, right? Okay, so here will be something interesting that the team provided for this during their training, and you see that there is some aha moment that the model can actually flag here, and they said wait. So it seems that this approach was not very effective, and they found another better approach, and then they corrected themselves. And if you have tried this model by yourself, and you can also observe that there are a lot of those kind of wait and aha moments when you use the R1 mode of this model, right? Good. So that'll be the main part of this paper, and you can later have a look by yourself if you're also interested in this paper, and you can also try this model out, right? So and again, as we mentioned, so the key part of this model, the success of this model, that would be the key would be the combination of this COT and this workflow, as well as this incorporating the reinforcement learning algorithms, right? So again, we can see the power of the RL algorithms, right? So, and later, if we have chance, we can also have a deeper look into the related algorithms that this model uses. Okay, good.